Hello everyone. Hope you guys are doing better than ever. Maybe your preparation for exams are going pretty well. And I hope you have subscribed my channel and you have followed the other videos which I have posted earlier. If you haven't done so, then just look out for other videos before we go ahead with the kinetic theory of gases. So today we are starting with kinetic theory of gases. This theory was developed by many scientists. A few of them are Boltzmann and Lammer, Pringsham, and there were many others who have contributed to kinetic theory of gases. This theory actually gave a molecular explanation to the kinetic energies, the pressure, the volume, and temperature. These are all external parameters, and external parameters got connected to the internal parameters like kinetic energy and velocities of the molecule. In order to understand kinetic theory of gases better, there are certain assumptions of kinetic theory of gases, and these assumptions are divided into two categories, part A and part B. Part A is regarding the nature of molecules and part B is regarding the motion of molecules. So if we are assuming these assumptions, the following assumptions, only then we can apply kinetic theory of gases. So let's see part A, that is the nature of molecules. So as we move down, we are here on the nature of molecules, and you can see there are four assumptions. There are four basic assumptions of kinetic theory. The first assumption is there must be huge number of molecules in a gas. So whenever you are going to consider a gas in a container, and if you are applying kinetic theory, then we should always assume that there is huge number of molecules, and we are not going to consider one or two molecules, or let's say 1,000, 10,000 molecules. So if you consider a container somewhat like this, then there must be huge number of molecules, and these dots are representing the molecules, and the molecule should be the number of molecules should be huge. So that's the first assumption. So kinetic theory won't be able to we cannot apply kinetic theory when the number of molecules is much less. Then comes the second assumption, and the second assumption says that the molecules are perfectly rigid. That means the molecules are not going to break, and even if they are colliding with each other. So molecules can collide with each other, but they are perfectly rigid so that they do not break after collision. And the collision can be between two molecules, and the collision can be between the walls of the container. So the molecules can collide with the walls as well as amongst themselves as well, but they are not going to break. Then the third assumption is the molecules are spherical in shape. They are spherical in shape and similar in size and mass. So when we are applying kinetic theory, we should make sure that we are considering molecules to be perfectly spherical in shape, and size and mass must be same between two molecules. So here you should note that molecules of similar kind, like if I have an oxygen molecule and if I have another oxygen molecule, then they should be identical. They should be spherical in shape, size and mass are same. But yes, if suppose I have a carbon dioxide molecule and an oxygen molecule, then of course these two molecules will have different size and shapes. But between the same gas, we can just say that the molecules must be having the same size and mass. Then the fourth assumption is volume of the molecules is much less than volume of the gas. So a gas has always occupied the volume of the container. So this entire box is what is the volume of the box, and this volume of the box is nothing but the volume of the gas. So this entire thing is the volume of the gas, and volume of molecules if I want to calculate. So let's say suppose I have this one molecule, and this molecule, and we have, let's say, 10 raised to 22 number of molecules. So I'll just have to multiply this. The volume occupied by the single molecule times the number of molecules will give me the volume of molecules. So this volume of molecules should be very much less than the volume occupied by the gas. So this is one of the assumptions of kinetic theory, in which these all four assumptions are basically based on the nature of the molecule and like how the molecule should be. And now the B part, that is the motion of molecules, like how the molecule should move. Let's see. Okay, so here you have four assumptions on motion of molecules. So the first assumption is that molecules are in a random motion, and this random motion is called as the molecular chaos. Now what does this mean? This means that whenever you have such kind of container in which you have a gas like this, then what we are supposed to understand is these molecules are continuously in a random motion. So the molecules do not stay at one point. I'll use a different color. Molecules continuously move in a random motion. They do not have any specific order. They continuously move in a random motion. That's why we call it as a chaos. There's no order. The molecules continuously move in a random motion, like in a crowded place. People randomly moving anywhere in any possible direction. This is what is called as a chaos. Okay, now the second assumption on motion of molecule is that all molecules move at the different velocities. Now here you should understand that even though their masses and the sizes are same, but the molecules can move in a random direction with variable velocities. Like variable velocities in the sense all molecules will have different velocities. No two molecules may have the same velocities. Two molecules will always have a different velocities. Okay, so that's where all molecules move with the different velocities. Then third is what is called as all collisions are perfectly elastic collisions. So now what do you mean by perfectly elastic collision? A perfectly elastic collision is a collision in which the kinetic energy is conserved. So if kinetic energy is conserved, we call it as a perfectly elastic collision. So just keep in mind that all the collision, be it between the walls and molecule, or between two molecules, a molecule and molecule, all these collisions are perfectly elastic collision. That means there is no loss of kinetic energy. Okay, so that becomes our third assumptions of kinetic theory of gases. Then we have this fourth assumption, in which it says that the collision time should be much less than must be less than the time taken to travel free path. Now what does that mean? Let's see, if there is one molecule here, let me do it a different color. Let's say we do it this one. Okay, so there is a molecule which is randomly in motion, and let's say this is a molecule A, and there is molecule B here, C maybe here, this is B, this is C, and let's say D is somewhere here. So the molecule A goes and hits B, and molecule A then comes and hits C, and then molecule A comes and hits molecule D. This is the path of molecule A. So when A hits B, B might go somewhere, but we are just tracking the molecule A. When A hits C, C might go somewhere else, and when A hits D, D might go somewhere else. But this distance is that distance in which molecule A is not colliding with anyone else. And same way, this is the distance where molecule A is not colliding with anyone else. And this is the distance in which molecule A is not colliding with anyone else. That means this distance, which I am marking with a blue, this distance is basically called as free path. Okay, and this distance is also called as free path, and this distance is also called as free path. So all these distances are called as free paths. So the assumption here is that the collision time, this collision time means the moment the collision has started and the moment the collision ends, that is called as the collision time, and that should be much less than the time taken to travel free path. That means this time should be larger, and the collision time, that is the moment the collision starts and the moment the collision ends, that collision time should be much less. So I can just give you an example of a let's say this is the wall, and let's say we have thrown a ball. This is a ball which is moving this side, and it collides. This is the moment when it just touches the wall, and then the ball slightly gets deformed like this, slightly oval shape, and then the ball again comes back to the original shape and it's just about to leave, and then the ball leaves. So the ball comes here. So this is the time when it starts the collision, and this is the time when the time ends, the collision ends. So the time duration between these two is called as the collision time. So this collision time should be much less than the time taken to travel the free path. So between two collisions, this time should be much larger and this time should be much lesser. Okay, we can there should also be one more addition of assumption. Let me do with a different color. Okay, great. That is collision between, when the one molecule is moving towards another, in between two collisions the velocity of the molecule is a constant. So between two collisions the velocity of a molecule is constant. Okay, so there is no point in increasing its velocity in the middle without any collision. So between two collisions the velocity of a molecule is a constant. That is the fifth assumption. So this is a theoretical questions. I hope you might have taken notes of it. In case if you haven't, you can just pause the video right now and take it from this. You can grab here and you can pause here. There's the 4 assumptions and this is your 5th one. I hope you have liked this video, and in case if you are following me from previous videos, then please subscribe and please comment on the channel so that I will also know what kind of videos you are liking, what errors I am making. Feedback is always welcome. Thank you so much. Bye.